fine materials whose grain size lies in the range of 1 to 100 nanometer. But when you talk about the size of any atom, so the typical size of any atom is in the range of 1 to 2 angstrom. So in 1 nanometer dimension, you can arrange 3 to 5 atoms. For example, if you have hydrogen atom, so the typical size of hydrogen atom is 1 angstrom, right? So in 1 nanometer dimension, how many hydrogen atoms you can arrange? 10 hydrogen atoms. So when you actually cutting down the materials and approaching to the atomic size, then you are actually touching the atomic limit. So when you touching the atomic limit, you could see the unusual changes in the properties and application of the materials because of each surface either it is a square or a rectangle. And area of square or rectangle is just length to width. Right? So for example, if the edge length of the cube is 2 centimeter, then the area of one surface, right? This will be 2 into 2. It means 4. 4 is one. Right? Now, how many surfaces are there? 6. So multiplied by 6. So the total covered area of this cube, this will be 24 square. 6 into 2 into 2. Now, if I say cut out this cube or extract the smaller cubes of edge length 1 centimeter, then how many cubes you will extract? 1, 2, 3, 4, 5, 6, 7 and 8. So you can extract or you can take 8 cubes from of edge length 1 centimeter from this figure. And now if I say to calculate the covered area of the surface area of these 8 cubes, how will you calculate? You will calculate number of cubes that are 8 into area of 1 cube. And the area of 1 cube will be area of the square into 6. Means 8 into 6 into 1 into 1. It will be 48. So this is the simplest example that I have taken. If you just reduce the size of a cube from 2 centimeter to the 1 centimeter, the covered area increase from 24 to 48 square centimeter. Not double, increased. This is another example. Increased, right? But when we actually work on the materials which are the nano dimension, nano means very small, then just big hypothesis, how many times the surface area will increase? Means just reduce the size of the object from micrometer to the nanometer. There is 1,000 types of the reduction in the grain size. Now you can correlate how many times the surface area will increase. And if you increase the surface area, how much times the surface property will increase. And if surface property will increase, the associated application will increase. Now, I am coming actually because this area, this slide is totally correlated with my presentation because I will speak about the catalysis. And everyone actually, either you belong to mathematics, physics or any branch of science or technology or chemistry, you have actually gone through the catalysis. And the basic property of the catalysis is the area, surface area. When any time of the catalyst actually gives the its surface. If surface is high, it increases the rate of reaction in the forward direction in many ways. So I will touch that part with this slide, but before that actually I will cover some basic part of the nanomaterials or the properties of the nanomaterials as said with this one. Actually when you highly interdisciplinary. Why actually you are sitting together under this academic development program which is based on the sustainable development. This is highly interdisciplinary. Everyone actually could benefit from this area actually. In that area you can't say actually you belong to chemistry, physics or the mathematics. Right? So you are only common in that. So now coming to the next actually is nano new actually. Actually this is the languages this is based in British Museum London from 4th century AD. Right? So that time actually this stuff sometime actually appears as red in color, sometime green in color. So it was assumed actually it is a kind of miracle. But there is no miracle actually. There is no rocket science actually. So now actually this part is clear because the gold metal exhibits a different color because of the oscillations of the electrons in different light and exhibit the different colors under the different size. Right? So when actually it could be seen in transmitted light, it appears as red in color. When it is seen in green light, reflected light, then it appears as green in color. So actually this nanotechnology has its roots from a very famous lecture which was actually delivered by a physics Nobel laureate, Professor Richard Feynman. He has delivered that lecture on 29 December 1959. And the title is so famous actually everyone remember it. There is no need to read that one. There is a plenty of room at the bottom. Means when you look over the bottom of anything, means if you look at small things, you will see fast changing. Means if you go for the smaller dimension, you will see the change in the property. And today actually we have that kind of a thing, and we are exploring a number of applications because of that habit. Right? Now ये मैंने गोल्ड का एग्जांपल लिया है, पर अगर आपका वो मानो कलर ऐसी है, राइट, तो हम लोग एक्चुअली यू विजिबल का देखते हैं, मतलब वो जो जब एक्सीडेंट करते हैं वो कहाँ पे एक्साइट करता है, बिकॉज ऑफ द ट्रांजिशन है, कलर अपीयरेंस है वो आपका जो आपकी जो ट्रांजिशन होती है, इलेक्ट्रॉनिक ट्रांजिशन, उसके ऊपर डिपेंड करता है. तो ये एग्जांपल गोल्ड के लिए बिल्कुल वो डिफरेंट होगा, ये जो भी कलर होता है गोल्ड.
लास्ट स्लाइड पर सर आपने दिखाया है
ज़्यादा चेंज कोई चेंज नहीं एक्चुअली ये जो सरफेस एरिया वाला इफेक्ट है ये नैनो में जाके डोमिनेट, जब हम नैनो डायमेंशन पे जाते हैं तब ये एक्चुअली इफेक्ट उससे पहले मतलब ये समझ लीजिए आप कि अभी मैं जब एग्जांपल ले रहा था आपके सामने, ठीक है ना, जब हमने नैनो का अप्रोच किया समझ रहे एक्चुअली अगर मैं अपनी बात करूँ या आपकी बात करूँ, आप ही सवाल कहाँ से पूछ रहे हैं ब्रेन, राइट, मीन्स यू आर टचिंग योर ब्रेन, राइट. तो वैसे ही जो मटेरियल होते हैं, जब मान लो फॉर एग्जांपल आपने मोबाइल में नंबर डाला था कि तो मुझको मिल गया था, समझ गए ना मेरी बात, तो वहाँ पे एक्चुअली ये कोई मोबाइल की अगर बात करूँ मैं, इसके अंदर कुछ ना कुछ तो है, कोई मटेरियल है जो ये सेंस कर पा रहा है, राइट, कि हमें क्या करना है, अगर आप दो करते हो तो आपको 4 देता है, ठीक है ना. तो वैसे ही एक्चुअली जो मेन रोल होता है वो एटम्स का होता है, राइट, मतलब ये मटेरियल के अंदर जो एटम होते हैं इनका खेल होता है, राइट. जैसे मान लो फॉर एग्जांपल निकल बैटरी, निकल है मेटल है ना, एटम, तो हम उसके एटम को टच करते हैं तो एटम्स का रोल होता है आपका, तो एटम का साइज होता है आपका एंगल्स का, राइट. तो नैनो में जाने का मतलब होता है डायरेक्ट जो है ब्रेन को टच करते हैं, इसलिए ड्रास्टिक चेंज है, प्रॉपर्टी में जो चेंज आ रहा है जो हम देख पा रहे हैं उससे पहले से मोटा है, वो उतना ऑब्जर्व करना बड़ा मुश्किल था. और जब हम लोग पहले साइंस करते थे, एक्चुअली जो नैनो की बात करें कब से आया, मैं एक्चुअली इसके पीछे नहीं जाना चाह रहा था. 1992 में जब बिल क्लिंटन आपके यूएस प्रेसिडेंट थे, उन्होंने $200 बिलियन रिलीज किया था नैनो टेक्नोलॉजी, तब दुनिया की आंखें जागी, अरे भाई नैनो कुछ होता है, समझ रहे मेरी बात. उसके बाद हम लोगों ने कुछ काम करना शुरू किया, 2000 के बाद हम लोगों ने बढ़िया से काम करना शुरू किया. 2000 से लेकर 2010 तक बेसिक रिसर्च और मिडिल रिसर्च पर हम लोग काम करते हैं. आज की तारीख में अगर आप बेसिक रिसर्च करेंगे पेपर आप एक में नहीं कर पाएंगे, सबसे क्या प्रोफेसर नहीं दिखाएंगे, ठीक है. तो जो बात आप कर रहे हो उससे बहुत पहले वाली बात लोगों ने बात सोचा ही नहीं था, ठीक है. पर जैसे यहाँ पे आया अचानक चेंजेस दिखाई देने शुरू हुए, और अब नैनो करने से काम नहीं बनेगा, नैनो कोई बात नहीं होता है, table or the size of chair. And now I think in one laptop, one mobile phone you can have everything. So this is actually the nanotechnology which enables you to reduce the size of the computer from half of the room to the size of the top. This one slide is based on the nanomaterials in the healthcare. Actually, the artificial bones that are made from nanocrystalline composites of the calcium phosphate, and their characteristic are similar to the natural bone, and strength is comparable to the scalar skin. The silver strips, because actually the silver nanoparticles can reduce the growth of the 100 types of bacteria, so the silver nanoparticles would find application to make these silver strips. So the result of these strips are 100 times better than the normal strips that are available in the market. With the help of the silver nanoparticles, you can provide the safer electrical fields. So if, for example, melanin content is there generally on Diwali or Holi or Eid or Gurprai, you would see the lot of actually mixing between manufacturing. So if you have that kind of a device at your home, so you can provide, you can check the actually impurity, it is present in the milk, and so this kind of, and the result actually you could see with the help of the name tag from here to the. Now coming to the basic part, actually the nanocatalysis. So when we talk about the nanocatalysis, so in our actually the chemistry of physics or the biology, this nanocatalysis we have classified in various branches, right? The organic organocatalysis, photocatalysis, electrocatalysis, photoelectrocatalysis, thermocatalysis. So many branches are there, but here actually at Jamia I am covering the 4 major classes: organic transformations, photoelectro and photoelectrocatalysis. Actually, if you without organic chemistry background, you could see the millions of the organic conversions are actually documented in your books, and most of those actually are supported by the inorganic activity. So if you are able to transform those inorganic activities into nanodimension, right, then actually you can increase all